Hello students, let us start with our next topic in our COA subject. In the previous class we have came across the control unit. In the control unit, the control unit has been classified into two types. One is nothing but a hardwired control unit and the second is nothing but a microprogrammed control unit. So what actually it is happening is nothing but in hardware control unit, the control unit has been designed by using the hardware circuitry. Whereas in the microprogrammed control unit, you will not be going to design by using the hardware. Okay, you will be going to use a small little programs to develop a control signals. Okay, all the functionalities of the control signals will be developed. So in our microprogrammed control unit, we will be going to come across this following topics. First is nothing but your control memory. Second is nothing but your sequencing micro instructions. And the third is nothing but your microprogram examples. And the fourth is nothing but your design of your control unit, microprogram control unit. And what do you mean by micro instruction format? Coming to the nano storage and nano programs, this is not there in your syllabus. Let us start with some block diagram comparison of your hardwired control unit and microprogram control unit. If you are going to see, the top block diagram is nothing but your hardwired control unit. So in this hardware control unit, you will be going to come across with a combinational logical circuits. You will be having a different combinational logical circuits. Using those combinational logic circuits, you will be going to develop the hardwired control unit. Okay, in the down diagram, block diagram, if you are going to say below block diagram, you will be finding a microprogram control unit. Okay, let us once again describe this hardwired control unit. I'll explain you, then we'll come to the microprogram control unit. If you're going to see in this hardwired control unit, you will be going to have the control data, where in that you will be going to have one register which is known as an instruction register, IR register. This IR register will be going to receive the data from the memory. With respect to this IR register, you will be going to have the status flip-flops, okay, which is going to give the status of your particular instruction which has been executed, or data which results. Based upon the data results, you are going to get the flip-flop results status. Okay, apart from this, the output of this instruction register and the status flag flip-flop, you will be going to give it to the combinational logic circuit to perform a certain combinational logic on the given data. Once the data is ready, that will be given to the control points, and from that control points it is going to generate the control signals to the CPU. And based upon those control signals, the CPU will process the data, and based upon that resultant data, the result data status will be given to the status flip-flops. Okay, when you go with this combination logic circuit, you will be going to have other side of the combination logic circuit is nothing but your control unit state. What do you mean by control unit state is nothing but in this control unit state, you are going to have two states. One is nothing but your timing state, and the second is nothing but your instruction cycle state. So in this control unit states, we will be having a timing states and instruction cycle state. What do you mean by timing state? A timing state is nothing but it will give you the information about the timing state information. This timing state will be going to synchronize the cycle. Okay, that is nothing but from one instruction to another instruction. Based upon that one, we require a synchronization, that is nothing but at the same instant of time only the instruction cycle should start its execution. Okay, next you will be going to have an instruction cycle state that is going to give you the information that now at present the instruction is, are you fetching the instruction, are you decoding the instruction, are you executing the instructions. So based upon that one, you will be going to have the instruction cycle state. So this state will be giving the information to the combinational logic circuit. Based upon that particular state, the data collected from the control data will be manipulated and the resultant control signals will be given to the control points. From that control points, it will be directed to the CPU. Okay, so this is something about your hardwired control unit. If you are going to see this hardwired control unit, everything will be done by using an hardwired type. Okay, now for example, if I want to develop a new control signals to control a particular device, so at that instant of time, what I will be doing, I will be designing my own hardware circuitry to implement the particular control signal. So for each and every control signal, if I am trying to implement any control signal, I need to design each and every time I need to design with a new hardware circuitry. So as the hardware circuitry is going to increase, what happens? My circuit complexity is also going to increase. So that will be a main disadvantage of my hardwired control unit. Okay, now apart from this hardware control unit, if you are going to observe it, if suppose in the control signals, if I want to modify any of the thing, then I need to modify in the hardware circuitry. So then to modify in the hardware circuitry, you know that what is a big headache it will be. Why? Because each and based upon the development of each and every component and IC configuration and the timing pulse and synchronization of each and every block, everything should be kept in mind. Okay, and the whole designing again is nothing but it is very costly. Okay, and there is a lot of chance that there will be chances of having a failure in this one. So keeping that disadvantages, they thought of going with a software part of control unit. In the software control unit, what we will be doing, we will be writing a certain programs for a given control signals. To generate a particular control signal, I will be writing a certain functions. Those functions are programs are known as a microprograms. Okay, now based upon our requirement, if I want to generate a particular control signal, then that particular control signal microprogram is already there in my memory. So it will go to that memory, it will execute that microprogram and it will be going to generate the result. So this will be goes on in the microprogram. And if suppose if I want to if I want to change something in my control signal, so what I need to do, I need to just open my microprogram, I need to modify the program, then again I need to dump it into the memory. Okay, do I require any hardware circuitry over here? We don't require any hardware circuitry to implement. So that is the main advantage of your microprogram. So it is very easy to debug it, very easy to implement, and how many control signals, if at all I want it, I can able to implement by using this microprogram control unit. So I require a very less, that is nothing but least hardware circuitry we require in implementing this microprogram control unit. So if you are going to see, this is a block diagram of your microprogram control unit. So what are the basic blocks we will be going to see? The first block, as you know that we do have a control data where I will be getting a data from my memory. It is stored in the instruction register and the status flip-flops. Now we will be going to, after this we will be going to have the next address generation logic. A next address generation logic is nothing but this is used to generate a address, memory address. Okay, memory address of my microprogram. So from where I need to go and I need to execute the program. So that is nothing but that memory address will be generated by this next address generation logic. The output of this one is given to CSAR. What is CSAR? CSAR is nothing but it is one type of a register. That CSAR is nothing but it is used to store the address of my control memory. Okay, so whenever we go with a microprogram, I have told you just now that a microprogram is nothing but you will be, for each and every control signal you will be writing a microprogram and it is stored in a memory. The memory which is used to store this microprogram, we are saying it is a control storage, or you can also say it as a microprogram memory. Okay, It is known as a microprogram memory. Now the address of this control storage is been stored in the control storage address register, which is nothing but a CSAR. So your next address generation logic will generate the address of your control storage, that is microprogram first starting address. That address is been moved to the CSAR, control storage address register. Based upon that particular address, your particular processor will go to the control storage memory in that memory location, and it will start execute that particular program. Once it finishes the execution of that particular program, the data which has been retrieved, that will be saved into the data register, which is known as an CSDR. CSDR is nothing but your control storage data register, okay, which is used to store the resultant control signal value, and that is given to the demultiplexer. Based upon this data, the demultiplexer will be going to generate a control pulses. So that is been given to the CPS, which is nothing but your control points. So based upon that which control point is been activated, your CPU will be going to react on this based on this control point. Okay, so this is nothing but your block diagram of your microprogram control unit. Before getting into our actual microprogram control unit, let us discuss few of the terminology we will be going to use it in this particular microprogram control unit. The first one is microprogram. What actually you mean by microprogram? The program stored in memory that generates all the control signals required to execute the instruction set correctly, and it is going to consist of micro instructions. Okay, so what is microprogram? A microprogram is nothing but it is a program which is stored in the memory, and that is used to generate all control signals which is required to execute an instruction set correctly. Okay, and this microprogram consists of micro instructions. Now, what do you mean by micro instructions? Micro instructions is nothing but it contains a control word and a sequencing word. So whenever we talk about micro instruction, micro instruction has been classified into two fields. It is going to have two different fields. One is control word and the second one is nothing but a sequencing word. What do you mean by control word? All the control informations required for one clock cycle. So whatever the control information we require for a particular cycle, that value will be stored in the control word. What do you mean by sequencing word? Information needed to decide the next micro instruction address. So whatever the information we required to decide the next micro instruction address. What is my next micro instruction? What is the address of my next micro instruction? That value will be there in the sequencing word. My next micro instruction can be the next instruction only, or it can be somewhere in the other memory location based upon my control signal. Okay, it needs to go there and it needs to execute that micro instruction. So that details you will be going to get it from sequencing word. So what happens? Your micro instructions is been having two fields. One is nothing but your control word field and the second is nothing but your sequencing word field. A control word field will give the information about all the control information required for one clock pulse. What is the control information we require for one clock pulse? That information will be stored in the control word. Next is sequencing word field is nothing but it gives you the address it gives you the micro instruction address where the next micro instruction should be executed. Okay. Next, what is the next one? Control memory. A control memory is also known as a control storage. We will be saying it as a CES. Okay. A storage in the microprogrammed control unit to store the microprograms. Okay, to store the microprograms, we will be using a memory, and that memory known as a control storage or control memory. What is WCS? WCS is nothing but a writable control memory or writable control storage. A control storage whose contents can be modified, allows the microprograms can be changed. Instruction set can be changed or modified. So what happens here? In writable control memory, I can able to change my program. It will be allowing us to change my microprogram or modify my microprogram. Okay, the instruction set can be modified. That is known as an writable control memory. That is nothing but your writable control storage memory. So that is nothing but a WCS. Next comes to the dynamic microprogramming. A dynamic microprogramming is nothing but a control system whose control unit is implemented with a microprogram in WCS. A microprogram can be changed by a system programmer or a user. Okay, so dynamic microprogramming is nothing but a computer system whose control unit is implemented with a microprogram in WCS. Okay, so that is something as a dynamic microprogramming. What is the next one? Is nothing but your sequencer or microprogram sequencer. A microprogram control unit that contains a micro instruction address to be executed in the next clock pulse. Okay, as we have came across sequencing word. Sequencing word will be going to give you the information of the micro instruction address to be executed in the next clock pulse. So that sequencer is nothing but it has been classified into different types. First one is inline sequencing, second is branch sequencing, third is nothing but your conditional branch sequencing, fourth is nothing but your subroutine sequencing, and fifth is nothing but your loop sequencing, and the sixth one is nothing but your instruction opcode mapping. When you go with an inline sequencing is nothing but it will be going to give you the information that now, as of now, the next instruction, the next exactly after this address, what is the next address is there? It is the next instruction is there in the next address only. So it is nothing but inline sequencing. One by one instruction, back to back one instruction is available. Those instruction is nothing but your inline sequencing. Branch sequencing is nothing but your, it will give you the address that somewhere else is there in my micro instruction. The micro instruction is there in somewhere else. That is known as a branch sequencing. And the third one is conditional branch sequencing is nothing but if at all this condition gets satisfied, then only go to that particular address and execute that particular micro instruction. Else execute the next instruction only. Okay, so that is nothing but your conditional branch sequencing. And the fourth one is nothing but your subroutine sequencing. Subroutine sequencing is nothing but as you go with the functions in your C language. In the C language, you will be calling a function to execute a certain program. Okay, in the same way, that particular function we are saying in our language, computer language, as a subroutine program. So we will go for subroutine program, we will execute that particular subroutine function, subroutine program, then we will return back to our main program. So that is nothing but your subroutine address sequencing. Fifth one is nothing but your loop sequencing. What do you mean by loop sequencing? A loop sequencing is nothing but few instructions. There are a bunch of instructions should be executed at least for 5 times or should be executed for 10 times or 1 time. So based upon our requirement, we will be using. So that is known as a loop sequencing. And the next one is nothing but your instruction opcode mapping. So you will be going to have an instruction. In that instruction, what is the opcode? How you are going to map it? That is nothing but your sequencer. So these are nothing but your different sequences are available in our microprogram control unit. One is inline sequencing, branch sequencing, conditional branch sequencing, subroutine sequencing, loop sequencing, instruction opcode mapping sequencing. So these are the different sequences which are available. Next comes the next terminology, which is known as a pipeline registers. A register that holds the current micro instruction being executed. This is needed when the micro instruction execution and the control storage access to the next micro instructions are to be overlapped for speed improvement. What is pipeline in register? You will be having a pipeline register which is going to hold the current micro instruction. What is the current micro instruction it is executing? That address it is going to hold it in the pipeline registers. Okay, this is needed when micro instruction execution and the control storage access for the next micro instructions are to be overlapped. So to speed the improvement, we will be using these pipeline registers. Okay, now let us come with your micro sequencing. Let us once again revise this micro program. Okay, then we'll start with the micro sequencing. So control unit is classified into hardwired control unit and microprogram control unit. In the microprogram control unit, we will be going to have a CSAR register. Let us revise this particular control unit once again. Hardwired control unit and microprogram control unit. A microprogram control unit will be going to have a sequence of micro instructions which is used to generate all the control signals. So the main thing is nothing but we will be having two registers. One is nothing but a CSAR register and CSDR register. What is CSAR register? CSAR register is nothing but your control storage address register, and the second one is nothing but your control storage data register. Okay, these two registers will be going to store the address register and data values based upon my control storage memory. Okay, the terminology microprogram is going to have a set of micro instruction which is used to generate the control signals. What is micro instructions? A micro instruction consists of two fields. One is control word field and the second one is nothing but a sequence word field. A control word field will be going to give all the control information required for one clock cycle, whereas sequencing word is nothing but it will give the information of the next micro instruction address. Where is the next micro instruction address? That address value you are going to get it from these micro instructions. Apart from this one, you are going to have the control memory. Okay, control memory is nothing but your control storage which is used to store the microprogram control unit. Okay, to store the microprogram. When apart from this one, whatever the microprogram is there, that can be modified by you in the memory known as a WCS. WCS is nothing but your writable control storage memory. Okay, next one is nothing but your dynamic microprogramming is nothing but a computer system whose control unit is implemented by a microprogram in WCS. Sequencer, when you talk about sequencer, very important for your final exam. He will be asking you that what are the different sequence of execution of your micro instructions in the microprogram. He will be asking you. In that you need to explain all this sequencing, and based upon this one you will be going to have a block diagram also that we will be going to see in the coming classes. Okay, when you go with a sequencer, that is nothing but where is my next micro instruction is available, how it has been executing. Okay, that sequence will be you are going to get it from your from these types of sequences. Okay, first one is nothing but inline sequencing. Inline sequencing, you will be going to give you the information that the next instruction is only the next instruction which is available, that is nothing but your inline sequencing. And the next one is nothing but your branch, which is nothing but your branching is nothing but somewhere else is there my micro instruction, go there and execute it. Conditional branch is nothing but if this particular condition satisfied, go there and execute my micro instruction. Subroutine is nothing but it will be acting as a function Okay, it will be going to call a particular function, that is nothing but a subroutine program. It will execute that subroutine program, then it return banks to the main program. Okay, and next one is nothing but a loop is nothing but few of the micro instructions to be repeated again and again, then we'll be keep it in the loop. Next one is nothing but your instruction opcode mapping. If I want to map the opcode of two instructions, then I'll be using this particular sequencer. Apart from that one, we'll be going to have a pipeline register. A pipeline register is nothing but it is used to hold the micro instruction which is at present which micro instruction is been executing. That address you are going to keep it in the pipeline registers. Okay, in the coming to micro instruction sequencing, this block diagram we will be going to discuss in the coming class. Thank you.